Alright, calculus, here we go with AB 43. That's what we're looking at, and it's differential equations. This is actually a very big topic in the world of calculus, but you guys are just going to get the very most basic concepts with them, focusing primarily on the idea of how to use separation of variables and then some integration techniques from there. Again, this is just the tip top of differential equations. There's much more than this, but let's go ahead and see what we can do with an introduction to calculus type course. So we start out with we have a bunch of derivatives, dy dx, dy dt, dx dt. It doesn't matter. There's two variables here. Then we're going to have two functions, an f and a g, you could say. One's going to be in terms of one variable, the other one's in terms of the other variable. So for example, this first one I see, it's kind of like saying dx over, or dy, pardon me, dy over dx. dy over dx is equal to, well, we have the 2x, and then over here we could also say 1 over y. So we have two functions, each a separate variable, and a dy dx. And what we want to do is get that so that the y part of the function matches with the dy and the x part of the function matches with the dx. So I'm going to leave this x alone here. I'm going to multiply both sides by dx. And I'm also going to multiply both sides by y. So that gets rid of the y over on the right side and the dx over on the left side. Then I would have y dy equals 2x dx. Okay, no big deal so far. You could even thought of that as kind of like cross multiplying. You know, it's just algebra, trying to get the y's to match with the dy and the x's to match with the dx. This 2 honestly could go on either side. The constant can kind of float, but the variables do need to match. But once I'm at this point, let's see what we would get. Well, the antiderivative of each side would let me get rid of this dy and dx. Those parts would be calculated out of it. So the antiderivative of y is really, well, it's y to the first now, but then it becomes y squared over 2. On the other side, we would have 2x squared over 2, because this is x to the first. Those two simplify. Now here's what a lot of people kind of get stuck on, because they say, oh wait, you need a constant in there, so like a plus c. Let's call this plus c1 and plus c2. Well, let's say I wanted to group those and I subtract c1 from both sides. Then I'd have y squared over 2 equals x squared plus c2 minus c1. Well, the catch is that those two constants, when you put them together, they just make a new constant. So I don't have to have multiple constants. In fact, kind of a general rule, you just need to have one constant of integration after you do the step of integration. So we'll have y squared over 2 equals x squared plus c. From here, it's just algebra. We want to get this y by itself, so we multiply both sides by 2. And wait, if I multiply this 2 to the constant, that's really 2 times a constant is still a constant. So I don't really need to multiply it to the constant, just keep in mind that it's still a constant. Then I'd have y squared equals 2x squared plus c. At this point we get rid of the squared on the y by square rooting both sides. Y equals square root 2x squared plus c. No problem. Super easy. Mostly because the integration worked out really well. And we didn't have a lot of substituting or any advanced techniques of integration. We will see some of that in this video very quickly as well. So let's get right into this next one. So now I'm going to work on the same idea. I got to first separate variables. So I look at this and I see that this is y squared and really times 1, I guess you could say. After we do some algebra, we move the dx over. We'd have dy equals y squared times dx, but that's a problem, because this y and the dx doesn't match, so I got to divide both sides by y squared. Then I'd have dy over y to the second power equals dx. At this point, I can integrate both sides. I can do the antiderivative of y squared, and I can do the antiderivative of this is really just 1 times dx. Okay, so a couple of tips. First, it's not easy to deal with a power that's not equal to 1 if it's in the denominator, as it is here. So I'm going to bring this denominator up. It will be y to the negative 2 dy. Still got to take the antiderivative. On the other side, I could go ahead and take the antiderivative of this. The antiderivative of 1 is just x, and of course we need the plus a constant. So let's keep working with this left side. Y to the negative 2, it's a power rule, so we're going to add 1. That becomes y to the negative 1 over negative 1. And then we still have the constant over on the right side, so we don't need to add in another constant on the left side. So from here, just a little bit of algebra, this is really going to say negative 1 over y equals x plus c. We do a little bit of manipulation with proportions, moving numerators, denominators around, and you would wind up having y equals negative 1 over x plus c. Check. No big deal. Again, very, very straightforward, pretty easy to do. Let's look at this next one and do it in orange. So the first thing I see when looking at this that's kind of a challenge is we have dy dx, but over here it's kind of like, well, okay, so I have this function up top and I got this function on bottom. I'm going to really say that's like x plus sine of x. And I'm going to move this dx over here, but then I'm going to move this 3y squared over with the dy. So I'll have 3y squared dy is equal to x plus sine of x times dx. Okay, we're doing okay so far. We got y's with the dy and x's with the dx. So we put it all together. Let's take the antiderivative here. So when I take the antiderivative of 3y squared, that's really 3y cubed over 3, which is really just y cubed. And on the other side, now I can do each of these separate because they're added in between. So some are difference of two terms or multiple terms. We can really do the antiderivative separate. So the antiderivative of x to the first power is going to become x squared over 2. Those 3's cancel, by the way. And then we have the antiderivative of sine of x. The antiderivative is negative cosine of x. And then, of course, the plus c. So the only thing I really have left to get rid of is this cubed. So to get rid of that, I'm going to take the cubed root of both sides. That would give me y equals the cubed root of this whole thing, let's say 1/2 x squared minus cosine x plus c. Excellent. Excellent. Easy. Let's keep going. All right, from here, we're going to have a few slightly more advanced examples, but they're all very similar. All 3 of these are very similar. Let's start with the first one here, number 4. So when I look at this, I need to get this y over to here somehow on the other side of the equation. I need to get this dx over to here somehow. So how would I do that? I divide both sides by y, multiply both sides by dx. So I'm going to multiply the dx over here, and I'm going to put the y over in the denominator on the other side. So we'd have dy over y equals 4 dx. And now you're probably wondering, well, why didn't you put the 4 over here as well? Why didn't we do that? Well, it doesn't really matter. Constants don't need to move as much as the variables do. I just need to get the y over there. If I move the constant too, cool, but I don't need to. So now I'm ready. I have y's mixed with dy's and x's mixed with dx's. There's really no x's, but I have this constant. So let's deal with that. Let's take the antiderivative of both sides. The antiderivative of dy over y, or the antiderivative of du over u, it doesn't really matter what these letters are, is going to be natural log. So I'm going to have natural log of y equals, and then on this side I'll have 4x, because the antiderivative of 4 is 4x. And then, of course, plus a constant. At this point, you got to do some algebra, some a little more advanced algebra to try and get rid of that natural log, because we just want y by itself. So let's raise both sides as a power with e in the base. So the e to the natural log, that's going to get rid of each other. Those are inverse operations. We'll be just left with y equals e to the 4x plus c. Excellent. Okay, so now that we're here, we have y equals e to the 4x plus c. And this is where it gets, there's a little bit of a detail here that we got to watch out for. And we're going to see it in all three of these. Whenever we have a base, let's just pick a letter. How about t? And if we were to say t squared times t cubed, that would be t to the 5th, because you take these two numbers and you add them together. So in other words, some base to a power times some base to another power means that those are put together, x to the a plus b. Now what we have is something that says e to the 4x plus c. So we have this plus happening here. That means that we started with e to the 4x times e to the c. So let's keep that in mind. Now we're going to make that little algebraic step. We have e to the 4x times e to the c. But here is where that whole constant being absorbed into a constant comes into play. E is a constant, c is a constant. A constant to the power of a constant is still a constant. So it's just e to the 4x times c. Now often this is actually written slightly different order. The c, a lot of times they like to put this in front. So they're going to say y equals c times e to the 4x. Whether that c is capital or lowercase, doesn't really matter. They usually do a capital. Alright, so that's the idea of dealing with this dy dx equals a constant times y. Now notice here, this is very similar. K times y instead of 4 times y. So if you can imagine, we're going to end up with something that says y equals c times e to the kx. Let's see how we would get there. Well, first thing, let's divide both sides by y. We're going to multiply both sides by dx. We do all that, we wind up getting dy over y equals k times x. At this point we can integrate both sides. Whoops, not k times x, k times dx. And the antiderivative of dy over y is going to be natural log of y. And over here on the right side we're going to have kx plus c. We raise both as a power with the base e. E to the natural log of y just becomes y. E to the kx plus c is really e to the kx times e to the c, which winds up being e to the kx times a constant, and then we put that constant out front. We get to the final step. Okay, so that's the idea. We got it so far. So number 6, what's the big deal with number 6? When I look at number 6, it doesn't seem right away like it would be that hard, but it's definitely different. And the difference is here. We have two variables, not a constant and a variable, two variables. So now let's deal with number 6. So when I'm looking at number 6, I would first move the y down here and the dx up here. So what would we get? We'd have dy over y, that's great, we know how to deal with that, equals x dx. So now let's integrate both sides. So I integrate both sides, and the integral, or the antiderivative I should say, of dy over y is natural log of y. No surprise there. But this other side, x to the first, is going to become x squared over 2, and we still have the plus c. Now when we do this e as a base to both sides, we are going to get a y on the left But on the right, we're going to have e to the x squared over 2 times e to the c, which is really going to be c. So y equals c times e to the x squared over 2. That wasn't too bad. Slightly different, but it still worked out just fine. Okay, so those are all very similar, and I really suggest actually watching these ones an extra time, because this is a very common format that you guys would see like on an AP type test. This whole idea where it looks like a simple derivative, but the antiderivative, when you do the differential equations, definitely winds up being a little more complex. Okay, now, oof, man, these are going to be messy. Let's do them one at a time. Do we have these separated? Let's see. We have an extra page here, and we're going to use it. We're going to do just number 7. So I'm going to take number 8. I'm going to take a snapshot of this. And we'll put that on the clipboard. We'll move that over to the next page. Paste. There we go. Let's deal with just number 7. So I'm going to cover up this number 8 so you guys don't have to think about it. There we go. All right, back to business. Number 7. How do we deal with number 7 here? Well, a couple of things are happening. First, u and t are kind of mixed into one term here. That's a problem because we need to separate them. Well, based on previous examples that we just saw right before this, we know that this is the same as saying du dt equals e to the u times e to the 2t. Well, that's convenient for us, because now when I look at this, I'm thinking, well, I could move this e to the u to the other side by dividing both sides, and I could multiply dt to both sides, get rid of those. So I have the e to the u's are gone, dt's are gone here. That gives me du over e to the u equals, on the other side, this is going to give me e to the 2t dt. Now I know from other formulas, I know that e to the u du, when I take the antiderivative, is just e to the u. So I need to have this relationship with the u and du happening. Now that's not what I have over here, down here on the bottom, on the left side I should say. This is really like e to the negative u du. So let's deal with that. Let's do a substitution. And in fact, just for cleanliness, instead of e to the u du, let's do e to the w dw equals e to the w. In that case, to deal with this e to the negative u, I'm about to take the antiderivative of that. And keep in mind here, I'm actually going to have two separate problems. So I'm going to have e to the 2t dt. I got to take the antiderivative of that as well. But I'm going to do these one at a time. So let's deal with the blue one. For the blue one, let's say w equals negative u. Then dw du equals negative 1. Do some algebra, you get negative 1 times dw equals du. Now I'm ready to make substitutions, because I can take out the negative u and the du and replace it with these other two parts, negative 1 dw and just w. So if I make that substitution, that would give me negative 1, taking this piece up here, negative 1 and dw, so now the du is out. E to the negative u is going to become e to the w. I could take that antiderivative. Well, the antiderivative of e to the w dw is just e to the w. And then the negative 1 is a constant, so that just kind of tags along here. Constant multiple rule. Now we can deal with the orange side, the right side here. And now I've already used w, so let's use a different letter. How about I don't know, v? Sure. Let's say v equals this piece right there, 2t. Then I would say dv dt, taking the derivative of both sides with respect to t, is going to equal 2. Do some math here, multiply both sides by dt, and I'm going to divide both sides by 2. Let's see what would happen. I'd have 1/2, and a dv is going to take the place of my dt. So I'll take this dt out, and I'm going to replace it with a 1/2 dv. So let's start with that. We got 1/2 and a dv. The dt's out. Instead of saying e to the 2t, it's going to say e to the v. All right, now I have e to the v dv, e to the u du, e to the w du. Much simpler format. So that constant 1/2, that's just going to sit outside, tag along. And the antiderivative of e to the v is just e to the v. So now I have it. I got -1 e to the w equals 1/2 e to the v. -1 e to the w equals 1/2 e to the v. But I need to figure out what w and v are. Oh, actually, I know what they are. So this is going to be -1 e to the -u equals 1/2 e to the 2t. So we do have some crazy things happening here. And a lot of it has to do with this negative. Because how do I get rid of these e's on both sides? I'd have to do a natural log, but one of these is negative and one of these is positive. And how do I deal with that? Well, let's see what we can do. I'd have -1 over e to the u equals 1/2 e to the 2t. And that's honestly close to where I can get. There's not, oh, pardon me. I'm missing a plus c. So let's say I did a plus c here. There we would go. So plus c. Now I'm actually going to leave it there because I'm a little kind of lost in thinking about how do I take the natural log of a negative, and over here there's only a positive. I can't multiply both sides by a positive or a negative. So can't really work that one out. Alright, so I'm going to leave that one there. Let's take a look at number 8. Now this is going to employ a skill not used too often. It's very rarely used. Because people would look at this and like, I don't know what to do, but I do know that I need to factor it. And one of these has to be in terms of t, and one of these has to be in terms of x. So let's see how I would go about setting that up. Well, I see that there's an x in each of these second terms. So let's take that somewhere. I would have dx dt equals 1 plus t minus, I'm going to factor out the x. So I'd factor out the x, and that would give me a 1 plus t. Here's where it looks really weird, because this actually has a common factor between the first half and the second half. The common factor is this 1 plus t, because the first one is times 1. The second one is times negative x. This is called factoring by grouping. So if you were to look up factor by grouping, or regrouping, I don't know how they would describe it, but it's usually factor by grouping. I notice that there's a 1 plus t common to both of them. So I'm going to pull out that 1 plus t, then what's left over? Well, I'd have 1, and then minus x. And look, I just factored it. So I got dx dt equals all this. Well, I got to take this x term, move it over to the left side, take the dt, move it over to the right side. So those two are going to kind of swap places. I'd have dx over 1 minus x equals 1 plus t times dt. At this point, pretty straightforward, integrate both sides. Wait, it's not so straightforward, because 1 plus t, that's not a big deal. That's going to become t plus t squared over 2. That's just power t to the first power. But on this side, I have dx over 1 minus x, and this is really x to the first power. The closest thing that this is near would be like a du over u, and the antiderivative of that is going to be natural log of u. Well, what would u be in this case, and how do I balance it? Well, u is going to equal 1 minus x. All right, we can do that. And that means that du dx is negative 1. Well, I have a dx, but I don't have a negative 1, so I need to move that negative 1 over. I'd have negative 1 times du equals dx. At this point, I can make a substitution. So this side here is really negative 1 times du, because I took out the dx and put in a negative 1 times du. The 1 minus x in the bottom is going to be just a u. So far, we've integrated the right side. Let's put a plus c with it. But we haven't integrated the left side. The antiderivative of du over u, not a big deal now, it's natural log of u. And u in this case is 1 minus x. But we need this negative 1 here. It's negative 1 times natural log of 1 minus x equals t plus t squared over 2 plus c. The algebra from here, somewhat challenging because we got to get rid of this negative 1 first. So we have natural log of 1 minus x equals negative t minus t squared over 2, and then with this plus c, it doesn't matter if it's positive or negative. Then you would do the e on both sides. You get 1 minus x equals all of this stuff. Sorry about that little bell in the middle, but here we go, continuing on. We still have e to the negative t minus t squared over 2 plus c. Now, because these are minuses and pluses, there is a little bit of algebra here, but this would really wind up being e to the, let's see if we can get this right, we would have negative t, so that's going to go in a denominator because it's negative. So is this. But then the plus, that stays up top. So advanced algebra here, seeing how this stuff fits together. We still have 1 minus x on the left side. On the right side, we have 1 over e to the t. Because this is subtraction, again, that's 1 over, so times 1 over e to the t squared over 2. And then plus the c, so that's going to be times c there. So finishing out this problem, we're going to have this times c, this whole term has to go onto the other side, and this minus x is going to become plus x onto this side. Then we have x equals, all right, here we go, 1 minus 1 over e to the t squared over 2. All times c, so we'll put that c in the numerator. There we go. Oh, that's a lot of algebra. All right, so that is mostly the algebra. I'm going to do the second part of this video actually after this. I'm going to post this. But the second part is really how do I deal with this c and how do I solve and calculate what is that c. That's what we're going to do. So let's stop this one here and I will see you in part 2.